Hello, my name is Fuzz Schroeder, and I'm part of the Scribe development team. And today I want to talk about some advanced topics in the CDK for Scribe Online. And we're going to be talking about querying with pages, and we're going to use some advanced C# techniques to do that. So with this, I'm trying to both go over querying with pages and the concepts behind that, and also to illustrate some advanced C# techniques that you can use in other areas as well. Hopefully that will be interesting and not distracting. And but if you do have feedback, I'd really like to hear about it at fuzz.schroeder@scribesoft.com. Okay. So the goals here are, first I want to explain the eager validation, lazy evaluation nature of a query. So what that means basically is that we want the query to be, we want to make sure the query is valid as quickly as possible, but then we want to get the data from the query on an as-needed basis. So we'll explore that a little bit with iterables. Then I want to talk about the higher order relationship between a query, a page, and an item on a page, and explain what higher order means and how those things relate. Then we're going to provide a generic implementation, and I'm going to try to show you a functional representation or an implementation, as well as an abstract base class implementation, so we can look at a couple different styles in C#. And then we're going to use two mock services that do different types of querying, and we're going to implement that generic implementation for those two different mock services so we can put it all together. Okay, so first I want to look at I'll do a quick overview of the sample services that I've created. We have a numbers query service, and that numbers query service is just going to return a list of integers, and you can get the next list of integers and move on from there. And then a names query service, where names is a first name and a last name of a person, and that's a little bit more modeled after a real-world API. So let's take a quick look at that code. The numbers service really is just an offset, an account, and we're going to do some validation on that eagerly, and then return a list of those numbers. So if I put in 0 and the count 10, I'd get the numbers 0 through 9 returned in a page. And then in the next one I could ask for the numbers 10. I could do an offset of 10 and also 10 again, and then I'd get 10 through 19. So that's the integer query service, a really simple service. All the types that we're talking about here are ints, so there's no unusual types. And we'll see how to implement that a little bit, how to implement paging across that a little bit later. And then there's the name service. And this is a little more advanced, but also more real world. And this just takes a model of a names request and returns a names response. And it's essentially going to use a data source in the back. It's a text file that has a bunch of names on it, and we're going to use LINQ to get those. But essentially it's going to model this off of what you might see in a web API, where you're asking for, you request something and then get a response. If we look at the request, it just takes a page number and an order by first, and that means order by first name, and if that is false, then it means order by last name. And then if we look at the names response, that's going to take, it has a list of names on it, so that's one page will have a list of names, whether or not there are more names to get, and then it also returns the current page number that you asked for. So those are what the services look like. Let's move back. Oops, wrong. Move back to PowerPoint, and so next I want to talk about some enumerable T and iterables. These were introduced in C# 2.0. and we use the yield return keyword creates an iterable construct, and that's a state machine that creates a lazy enumerable using the yield return keyword. And I just want to demonstrate that it makes the entire method lazy. So let's take a look at some code. Okay, so I've got a program here which is going to call my get method. Then it's going to print to the console, did it work? And then it's going to actually do a no-op for each over the results, which are going to be enumerables. So let's look at this too lazy version of get. The first thing it does is throw an invalid operation exception. So this should demonstrate to us the laziness of this. So I'm going to actually debug in here. So if I start. So we call our get method, and it didn't throw, if you'll notice there, even though the first line of the get method was should have thrown an exception, it hasn't called that method yet. And what I want to illustrate here is that it doesn't get called until we start enumerating over that. And there it's going to throw the exception. So that's not really what we're looking for in a query, because we want, if the query is not a good query at all, we want to know about that as soon as possible. So let's see how we can implement that. Stop that. So I've also implemented this get2 method. I'm going to set this to call get2. And get2 looks very similar to the first implementation, but it breaks the yield return part of the operation into a separate method. So what happens here is the yield return method, the method with yield return is going to get turned into an iterator block, which is the lazily evaluated method. But the part where we do the validation there will get called right off the bat. So let's debug that. So if I walk through this, notice it goes right to the exception, and we throw that right off the bat. And that's more what we're looking for with a query. We want to do as much validation on the query as fast as we can without loading everything into without loading every page. So that's what we're looking for, and you're going to see that pattern in the later implementations. All right, so just going over that eager validation part, we want to evaluate these, we want the queries to evaluate lazily. So the main reason to do paging in a query is, for example, if you had 1 million items, you do not want to bring all 1 million items over and then start handing them back to the job. You want to get a couple items so that your memory stays small, and then on an as-needed basis, go get the other items as they're needed, so you can keep the memory size reasonable. And so we do that by separating the two blocks so that one's lazy and one's normal evaluation. And then we've already demoed that. In order to implement paging, we're going to use C# generics and func, which is kind of a shorthand for a function, although it's not exactly a function. And these were added in .NET 2.0. At least they added the generics, and that was designed by Don Syme of Microsoft Research, who later went on to design the F# language, which is interesting because F# is a functional language, and Don Syme had a lot of functional ideas put into generics for C# and .NET. Func and action T are similar to a function that takes a parameter. Our function returns something and an action returns a void. And those are introduced in .NET 3.5 with link, but they also have a lot of other uses, and you can pass around functions, which can be interesting. We're going to use these to create a generic higher order solution to the query paging problem. And we're going to show you 2 different implementations of that. There's going to be one using an abstract method, and then also an implementation that passes around functions, just to demonstrate the flexibility that we have. So when we're talking about queries, pages, and items, I just want to go over what these things mean. So a query requests a page. So you'd call a query and then get back a page. A page contains items, a list of items typically, and an item is the type of object that is ultimately yielded. So that's what we're actually returning or enumerating over. And these are higher order relationships, so a query, page, and item. They do not have any particular implementation. There might be a lot of different implementations of these things, but what's really important here is that the relationships between those hold, and we have to define what those relationships are in a generic way. And it's the functions between those, and that's what I mean by relationships, that define the behavior of a query page. And so what a higher order problem means is that a function that takes another function or returns a function, that's what makes up a higher order function, just to explain that term. So generic types and parameters in funcs, typically we prefix type parameters with a T. Funct of T means a function that returns a generic type T. Function of T input, T output is a function that takes a type T input and returns a T output. And the names T input and T output there are meant to provide some context but don't have any real meaning other than as hints. So now on to describing the parts that we're talking about and defining those relationships. A query or a page-specific query is something that can be created from the previous query and the previous page. The first query needs to be created with neither of those, so it has to be created, you have to generate the first query, and we do that in Scribe Online by converting a Scribe query into that initial query. A page is something that is returned from a function that takes a query. So we call a function that takes a query and returns a page, and then items can be yielded from a page. So we call a function that gives us a list of items. So let's take a look at some functions that get across that idea. Here I have an interface for an iQuery paging, and it has our three type parameters there, the tQuery, tPage, and tItem. That first function, execute query, is really the overall concept that we're talking about here. So that's you execute a query and it returns an enumerable of T items. But when we break that down into the different parts for paging, the parts that we need to make this all work are a function that gets a page given a query. We need to be able to get the next query given the previous query and the previous page, and we need a method to know whether we have to get more. So a has more method that looks at the current page and it returns a Boolean, and if it's true, then that means go get another page. And then we need a function that returns a list of items from a page. So if you look at those types there, tQuery, tPage, and tItem, there's no constraints on those. So there's any type that can perform these functions will do in this case, as long as you can make those functions work. So putting that together into a generic implementation, this would be the first part. So if you remember back to when we talked about eager validation and lazy evaluation, this is the first part of that method. So we want to execute the query, and we go and get the first page. So if we can get the first page, that's going to validate that the query was well formed. And then we're going to pass that page down into a second query implementation, and we're passing the query and the page along to that other implementation. And that's the thing that's going to use the yield for operation to create the enumerable out of that. So let's look at that implementation. So here we have the execute query implementation, and at the top there we're keeping the current state of the page, the current query, and whether or not we have more. We then yield return the items that we've gotten from the current page. So if you look there, we have, we've got a method that we use the getItems method to return, and the current page to return the list of items, and then we yield those back. And then we use our has more function against the current page to tell if we have more. If we do have more, we get the next query from the current query in the current page, and then we get the next page, and we set that to now the current page, and we set the current query to the previous query, and then if we still have more, we reduce or we iterate over that next page. So this implementation here is generic for any tQuery, tPage, or tItem, and it performs the mechanisms of a page and query. So let's see how to implement that for an integer service, for our integer service and the name service. Switch back into Visual Studio. So first I'm going to show you a couple of these implementations. So here's an abstract class called a query paging base. And if you can see, that's the first implementation there, or the first part of that. And here's the second. And then we describe 4 abstract methods that need to be implemented on any implementation of this class. And that's our get page, get next query, has more, and get items. Another way of implementing this, and this is going to look funny to those of you who are not familiar with functional programming, in the C# syntax is pretty verbose, but you can pass the functions all the way through the methods. So we're passing the tQuery into that first one, but we're also passing our get page, get next query, has more, and get items method. And then on this one we even get more, so we're passing everything all the way through. And so that's a stateless version of this, just more for academic reasons. So let's go look at some implementations here of what we have. So I have my query integer. So I've implemented these as a static class, and my get page. First I want to actually go over what the different types that we have for this implementation are. So let's look at this in a little more detail. For the names, or for the number service, let's go find that. If you look at what our query is, it's actually 2 ints. So I'm going to define that as a tuple of ints, or a tuple of 2 ints. A page is an I list of ints, and the item that we're talking about is an int. So let's go back at how you'd implement our implementation for that. And so the get page is going to take a query, which we've defined as a tuple of 2 ints, and return an I list of ints. So I call the integer query service with my item 1 and item 2, and that should return an integer page. The get next query method, remember that takes that will take a query, which you define again as a tuple of 2 ints, and a page. And all we're really doing in this case, we're keeping the count the same, which is here, and we're adding the count to the offset. So the query is very simple in this case. We just iterate, just increment by the amount of the count of the first list. I've created a really kind of silly has more here, so it's just going to count until the page, the 9th element of the page is less than 11. So if it gets over 11, it's going to stop continuing. And then the page itself, or the items, I need to return an I list, and the page already is an I list, so we don't have to do that. We just have to return the page. So it's just returning itself. So I've now taken this this get integers class here, which derives from query paging base. And if you look at that, I've defined that there's the query. So again, the tuple of int to int, the page, which is an iList of int, and the item, which is an int. And I've just replaced all of the overrides here, the get page, the get next query, the has more, and the get items with the query integer implementations that we just looked at. So if you want to look at those, that just is straight calling that's those static methods. So let's try to run this in the program. I'm going to code that up right now. So let's get rid of this part here. var e equals, oops, get integers. So we're gonna So again, the query is a tuple, so I'm going to, actually I don't need a new there, I need a tuple.create. And I'm going to pass in 0 for my offset, and we're going to get page sizes of 10. So, an execute query should return an enumerable of ints to us. Okay. And let's write these out into the console. So, okay, so we've implemented that query for our integer service. Let's see what happens. See what our first integer was 0, 1, and then if we let that run, I'm going to want to, you can see that we're writing out 0. Don't want that to go all the way to the end. So that enumerated over to the first page and then the second page. And then because that number was higher than 11, so we decided it didn't have any more, so it stopped returning pages. So we did that for the integer service. That was the implementation for that. We'll let that run to the end. And now we have to implement it for the names service. So if we look at the names service, this has, for its query, it has a names request. The page is a names response. And what it's returning for an item is a name. So let's try to implement that for this service. So the getPage function takes a names request, which is our query, and returns a names response. And so we're going to it just simply calls the query against the name query service. The getNext query takes the query in the page, and it uses the same order that the first query used, and then it increments the page number by 1. So that's one way to get a new query. Some of the next queries can be more advanced. Some are simple like this. Has more. Page has its own more property on it, so we're just going to leverage that and return that. And then get items. So the page itself has a collection of items, of names, and we're just going to pass back that collection. So it's a little bit different than the numbers query, which was just the page. This is a property on the page, and that's more typical of a web service. So I think what we want to do here is kind of implement it in like this. I'm going to do a little cut and paste coding. And this is going to be get names. And our types here again are going to be for the query, it is a names request. For the page, it's a names response. And for the item, it's a name. And then I'm going to have to say using names. Should make those work. Now we've got to properly define these methods. So we've got to fix this up here. So all the list of ints I need to turn into names responses. All the queries, I've got to make names requests. That has to be a name. I think those signatures are correct, but we have to use our query names implementations. Okay. So that should be our implementation of the query paging base for names. Build that. I got an error. So I didn't fix that type there, and the compiler will let me know, which is either one of the benefits or the curses of typed programming like this. So that should be a names response. Or actually, no, that's the query, so that should be the names request. And we'll rebuild that. And then we'll go back to our program. And we're going to change this to get names. We've got to create our initial query here. So new names request. And the order by is the thing we're looking for here. So order by first, we'll say true. And page number, I'm going to start at page 0. So we have to create our initial query that we pass in to this mechanism. I'm going to change the name of this because this is really a name now, although type inference works for us here. So it's the exact same implementation for the completely different query service. So let's see how that works. So I'm going to run to here, And the query looks like a names request. I'm going to step into that just so we can see what happens. And we get our first page. I'm going to step all the way in. So the request is not null. The page number is 0. We're going to create a order by first function for link. Walk through there. And then I'm reading from a, this names data is, it's got 900 names in it, and it's from a text file. I'm just using link to read through that for this implementation. We're going to get those values and return the response, which is going to be, so I'm taking 10 from this and passing those into the names response, and I'm giving back the same page number, and then I'm giving the count as 10. So that's this is the implementation of whether or not there are more left. So essentially I'm saying if there's a 10, if the count equals 10, that means there are more pages to go. Again, that's a silly algorithm for that, but it's a simple one to implement. We'll just go back to our execute query. Now we're going to walk over all of these, and you can see our name is Aaron Riso, so it's ordering by Aaron. And if we run to the end, we can look at, we got 900 names ordered by first name. So that page inquiry, and the pages did come by 10 at a time, and so we were only loading 10 at a time into memory on the client side. So we implemented that, but we did generically for both the number service and the name service, which is pretty interesting technique from my point of view. Okay, let's go back to our PowerPoint. So if you looked at that implementation, you might have noticed that the implementation for the name service was against an static member. And typically that's not actually the case. So typically you have to instantiate a service, authenticate against that service, and then use that service to make the call. So there's a couple different ways to implement that, but I did want to show you one other technique that you could use for the more functional method. So we could initialize that dependency in the query page base, and I'll go back to the code for that. So if your service or if your integer service, say instead of calling a method like, where's my, so instead of calling it a service like that, where the name query service is a static class, typically you'll see something along the lines of var service, oops, service equals new service, and then you call, this is going to be pseudocode for here, I'll show you another example in a little bit, and then the service calls the query. So it looks, typically things will look a little bit more like this, if that makes sense. I hope it does. And so in order to implement that, one way you can do that is by going into the get number implementation, or get integers implementation. So in this class here, I could have a private iService of these types. And then in my getPage function, instead of calling this static implementation, I could use that service to call that. So that's one way of doing that, using the abstract base class method. But if you're using the more functional method, I want to go over the concept of partial application, which can take functions that might have a different signature than you're looking at and turn them into the functions that you need. So if we look at the partial application code, you might pass in, or you might have a getPage method that takes a query, which you need for this implementation, but it also takes a service and then uses that service to call using the query. I can turn that into the function signature that we need, the func of query that returns a page, by applying the service partially. So what we do here is we create a lambda that takes a query and applies that service. So if you look at this code carefully, we're partially applying the service, which we're passing in from here, and returning a method that needs to get past a single item, and then it's going to call it as the query. So at the end of the day, we're going to end up calling this method, but we're applying the service first and then returning the function that has the query, that needs to take a query later on, so that you can apply that within the mechanism that we defined earlier. So that's it's a similar idea to currying, useful technique in a lot of cases where you need a certain type signature, and I just wanted to go over that quickly. Let's go back to our PowerPoint. And so far we've described everything here in very generic terms. Eventually you have to get that back into Scribe Online. So in Scribe Online, we're dealing with a Scribe query, and we're dealing with data entities as the item coming out. So in order to fit this query paging mechanism, you have to convert the Scribe query into a T query that we talked about in our implementation. And then you have to convert your T item into a data entity. And I'm just going to very quickly go over what that looks like. So in order to do that, you need a method that converts the query, and assume that's a Scribe query for now, and it converts the Scribe query into the T query that you're going to use inside of your paging mechanism. And then you also need a convert item method that converts the item into a data entity. You have to define that for your own data sources. And then the code to call it looks something like this. So we're assuming that we have the abstract query paging base that we defined earlier, and you convert the query using the convert query method, and then pass that into your paging mechanism, and then just use link to convert that enumerable as it walks through the items. So it's really simple to convert that, and you can do it in any kind of pipeline that you like. And it's a very useful technique, especially with enumerable type things. So that's just what we talked about right there. So in closing, in order to do paging in Scribe Online, it's useful to use the yield return in a secondary method to get eager validation. So that means if the query the query is badly formed or is not going to work, we want to know that information before we start enumerating over the items, and then pass that information back into a secondary method, so that we get the lazy evaluation, which means we get those values on as need to know, or as we need them. Sorry, I went too far. And then we use generics to define the higher order problem of queries, pages, and items, so we could define the relationship between those and then implement them generically. And then we showed the implementation against two different mock services, which can show the flexibility of that. So I hope you can use this in your query paging. And again, if you have any questions, feel free to email me at fuzz.schroeder@scribesoft.com. Thank you.